The Giga Casting supplier that Tesla uses, Hydra Group, just posted this morning a video of Sandy Munro talking about Tesla's Giga Casting advantage and how every one of the legacy auto manufacturers are now headed this way. Sandy lists out all the companies that are doing it, but he also singles out Volkswagen as the only company not able to do this because they have to cut costs. Today, we'll review all the various ways Tesla has an advantage over legacy automakers, and we'll review Sandy's predictions of how many years a head start that Tesla has. We've got Hans Nelson joining us. He has his own YouTube channel called Hans C. Nelson. Thank you, Hans.
Thanks for having me, Herbert.
This is a topic you and I have been talking about quite a bit because it's one of the things we need to understand is how much further ahead is Tesla? Are they ahead of legacy automakers? In our minds, it's very clear that they are. And so it's nice to hear Sandy Munro, right? He's an expert. Munro and Associates, they break down hundreds and hundreds of cars. They know what goes into each of these. They know the suppliers. They know the tech. And so when we hear Sandy talk about it, it just solidifies how much further is Tesla ahead. So let's go ahead and watch this video. This came from a tweet from Luca Greco. This video, Sandy talking about Giga Casting, was just dropped this morning by Hydra Group on their YouTube channel. And basically the summary is Sandy says everyone is moving in that direction except for Volkswagen. They have to cut 1/3 of their entire company and have no money left for R&D. This is breaking news from yesterday that Volkswagen announced, or at least they did internally, that they have to cut $10 billion. Actually, 10 billion euros, which is $10.9 billion. They'd have to cut staff, and their Volkswagen brand associate said that they cannot be competitive at this stage. So let's watch this video, and then we'll get your comments on it.
I know that the Japanese and the Koreans are moving in that direction, in a direction toward castings. I know that the car companies that we have in the United States are also moving in that direction. But it's not the whole of Europe that's not moving. Because Volvo just made an announcement yesterday saying that they're going into production with their casting units. I know that Stellantis is moving in that direction, so France. I know that Fiat, which is part of Stellantis, I knew they're moving in that direction. I know that BMW is looking at it, and so is Mercedes. The only company that I know that's not moving in that direction is Volkswagen, and probably one of the main reasons for that is because they're looking to cut costs. They're looking to cut a lot of costs. 1/3 of the company has to disappear. So they have no money for R&D. That's probably why, when you said Europe, I kind of think that really and truly it's only Volkswagen that's got a problem. I think the rest of the world is moving toward castings. I think that the future for Giga Castings and Mega Castings is always going to be, as long as we're looking at structural componentry and whatnot, and cost savings, everybody's going to be moving in either like what we used to call Mega Castings and Giga Castings, which I think is a better route to take. So, and the reason is simple. It's just better business.
Hans, how many years ahead is Tesla? Because they were the first to implement Hydra's Giga Castings, and now, as Sandy said, everybody's following it except for Volkswagen.
Yeah, I wish that I remembered when we saw the first Giga Castings going into production for Tesla. It's been a number of years now that they've been doing that. They do that in Shanghai with the Model Y, and also they've been doing that here in the United States as well. And so I don't know that we have any other auto companies that are actually in full volume production yet. And so, I mean, it's at least several years. There's a couple of key pieces of technology that you need in order to produce a Giga Casting. One of them is obviously the machine, and that's what Hydra and LK Machinery make. The other thing is you have to have the metallurgy. So you have to have an alloy. Typically, everything that's used right now is aluminum. There's potential that that's going to change more towards magnesium in the future. But right now, aluminum is the primary casting alloy that's done in these Giga Castings. And in order to get an aluminum alloy that you can shoot as fast as they need to shoot these, and for it not to need to be heat treated afterwards, which would completely eliminate the ability of that casting to be very dimensionally accurate. That's like an extremely difficult challenge from a material science standpoint. And so Tesla developed that alloy in-house. So now other companies are having to probably re-engineer, either license that alloy or re-engineer their own version kind of from scratch. They do have a proof point. They can kind of reverse engineer it. They can, tear it down at Tesla. They can kind of see what's in it, and they can work on their own. But that is something that they're ahead in. And then the last piece is, I know that Tesla developed in-house their own physics simulation software to be able to predict what the performance of that casting will be as they shoot that molten aluminum into those dies at those speeds. They had to make something custom on their own because all of the off-the-shelf software that they had didn't really do that very well. And so there are going to be off-the-shelf softwares now that are trying to match that level of performance that Tesla had. But each of these different areas are areas, except for being able to just buy the machine straight off of, a company like Hydra. Those are things that other companies are having to catch up in just to be able to start production. And Tesla already has several years worth of experience doing this, not only in small batch, but like in large scale production. So that's one of the reasons that everyone is going this direction, is just because it's cheaper at volume. And like Sandy said, it's just better business because you get more dimensionally accurate parts. You have less robots that you're having to do all this welding that has less dimensional accuracy. So it's less processes, less time. It's more expensive to set up at first, but then as soon as you get it installed, man, you're just knocking out perfect part time after time after time after time. And it makes the assembly process so much more reliable, so much better over the long run.
I just checked, and it said that Hydra put this in their catalog in 2018, and Tesla implemented it in late 2022 in their Model Y. Now, and then it takes, so once you decide you're going to do it, it takes years for you to actually, configure your factory, configure the car. It's a lot of work together. So just because they've announced they're going to do it, it's still going to be several years ahead. Mm-hmm. This table here is very interesting. It shows that this was what Sandy Munro said in 2021 when he was asked how many years ahead of competition is Tesla. And down at the bottom here, let's focus on this first. It says Giga Casting. He said 10 years. 10 years of ahead of the competition. So if they started talking to Hydra in 2018 and they implemented 2020, it's now 2024. So we're talking 6 years ahead. Now these guys are deciding to do it now. So there's at least 2 years. So it's maybe 8 years. But it could
one of the things
longer.
that we can even see that Tesla moving at Tesla speed, they did not put the rear Giga Castings in the Highland Model 3. And one of the reasons was that it would have required a much more extensive shutdown in order to reconfigure the Shanghai factory in order to do that. And so they decided not to for now. I'm sure that there will be Model 3s in the future that have those Giga Castings. So that's one example that even Tesla at Tesla speed is not just throwing these into the mix of changing over one production. Like when they set up a new line, they set it up with Giga Castings, but they don't transition existing lines over to Giga Castings willy-nilly because it's quite an ordeal. And so this is something that all the other legacy companies, that they already have their factories set up, they already have their welding lines, all their robot, like they have everything configured currently for the legacy process of building a body in white. And it's a big change. It's a huge switch, and it's something that they're going to have to move through deliberately, and it will take time.
Yeah. And then with Volkswagen announcing they can't do it because there's cost savings. Well, how are they going to ever catch up in cost savings? Because Giga Casting is one of the biggest reasons to reduce the price of a car. Now, let's take a look at the other areas that Sandy says, based on his experience of tearing down hundreds and hundreds of cars and their experience of knowing how much the parts cost and manufacturing costs. He thinks in motors, 3 to 4 years ahead. Thermal management, 4 years. Wiring, 4 years. Batteries, 6 to 7 years. FSD chip, 10 years. Let's go through each of these and give your opinion on them.
Yeah, I mean, as far as the mass manufacturers are concerned, so he's torn down a lot of motors by people like BMW. I don't know if they've torn down yet any of the Chinese vehicles, but yeah, everything coming out of Ford, like all of the major legacy players, and Tesla continues to come out far on top among those players. Lucid has a great motor. It's just not one that can be mass produced currently. And so that is just a caveat to keep in mind. He's not throwing a Lucid in there when he's saying that, just because they're not playing at the same sort of volume. And that motor is not something that competes on, even though performance is excellent, it's not going to compete in manufacturing cost with what Tesla's putting out there. And so there are different motors. You know, one motor may be cheaper, but it's not going to have as good of efficiency or performance. Another motor might have a little bit better performance, but it's going to be way more expensive to produce. And so just when you add up all of the different factors, Tesla's significantly ahead still.
Next is thermal management.
Yeah, so that is a great piece. You know, this was something that Sandy really tooted Tesla's horn on for a long time. You know, first they came out with the super bottle, and he thought that was really just the coolest thing ever. And then they turned around and scrapped that whole idea and put in the Octav Valve and the heat pump system. And there's no one who is able to manage temperature throughout the vehicle as efficiently as Tesla, and definitely not in such a compact, space-saving package that Tesla's able to do that. And so, yeah, the Octav Valve is really just a triumph of engineering. And as far as I know, there's no one else who has anything quite like it.
Yeah, I've heard this Octav Valve was a big deal for Sandy Munro's associates. They thought it was an incredible invention because of the savings and just the beautiful thing about combining everything into one part, and it made so much sense. This next one, though, wiring.
And it also has a huge impact on the range of the car. Like all of anything that you need to either heat up or cool down, that takes a lot of energy. And so if you can be more efficient in the way that you do that, then that means you have more energy left in the battery to drive. And so this has been a huge thing, actually. Like the cold weather performance of Tesla's has been significantly improved by the new thermal management system. And, you know, that's something that if you live in a cold weather environment, you're going to look at a Tesla EV much differently than you're going to look at a legacy EV, because the legacies are not going to have as good a performance in the cold that a Tesla would have.
And then this next one, wiring. This is the one that I did an interview with Corey Steuben, and he made a really big deal about how important this is. If you take a look, and he did, and he showed photos of the cars today, there's these orange wires everywhere. And they're very thick, and there's so many. But Tesla had three major orange wires, and he said that just absolutely reduces cost. Can you explain a little bit more about that?
Yeah, I mean, a lot of that wiring is either very heavy or very large. It can be either aluminum or it can be copper. And then it's very hard to install. So not only did they reduce the total amount of wiring in the Teslas, which also adds to the efficiency, you know, for every foot that an electrical signal has to go through a wire, there's a certain amount of resistance to that. And so if you reduce the total number of feet in your wiring harness, you're reducing the overall resistance in that, which basically equates to you have less electrical losses in your wiring system. So we have less losses. Then they've also changed in a lot of places. They've made the wiring, they've put it in a hard, rigid tube, or they've actually made the tube itself electrically conductive. And that makes it much easier to install than having to squish, you know, flexible wire all over the place and secure it into areas. If you just have an attachment point at one end and another attachment point at another end, then that's a much easier assembly process for a technician. And so, you know, just once again, they do things so thoughtfully and they get there through this iterative process. They just continue to make it better, and they make it better. Engineering is usually a discipline of trade-offs. You say, okay, I'm going to make this thing better at the expense of that thing getting worse, and I'm going to find through a set of analyses what's the best way to get that trade-off that gives me either the best cost or the best performance or whatever it is that I'm optimizing for. And what we see over and over again with Tesla is they're able to actually almost have to trade off nothing, and like they make every dimension better. It's like if you're playing Street Fighter and you have the one thing, the guy who's maxed out in every single metric, instead of having 100 and then 60 40 30, and that's the way that Tesla's actually able to engineer their products, is they just max out everything through this very innovative process of just changing things little by little over time.
And this is what this chart shows, right? It's just crazy that it's not just one thing. There's multiple things. And in fact, there's going to be 3 more things we're going to share in addition to this list. So wiring is a big deal, thermal management, motors, batteries. We know that Tesla has been just working on it. This is their big research and development, and no one else has been doing. None of the legacy auto manufacturers have been focusing on batteries. They just, they're buying it from third parties. Tell me what you know about Tesla's, head start here.
So especially when you look at the high nickel chemistry batteries that are going to be your power dense batteries for applications like the Cybertruck or the Tesla Semi or the Model S Plaid, they're extremely good on battery chemistries that are reliable, that last a long time, and that have good power density. A lot of that work has been done with people like Panasonic. And then with the 4680, we'll see, actually, I believe Tesla will develop their own battery chemistries that will be in-house battery chemistries. That's going to be really fun. I'm extremely excited to see what they come out with for an LFP 4680 that I expect to be LMFP. And then we'll kind of go from there. But that will allow them to go head to head with some of the Chinese LFP packs that are manufactured in a different way than the 4680, but they're able to do those well and at scale. So the one area where Tesla's niche is that 4680 and the high nickel chemistries currently, whereas Chinese manufacturers really specialize in the LFP chemistry, which is really a great entry-level vehicle chemistry. That's probably going to be the chemistry that the next-gen vehicle uses. It's also the primary chemistry used for energy storage deployments. And so we don't really see anyone aggressively trying to enter the market and make batteries at scale that are more power dense than the LFP chemistries. And so that's kind of an area where Tesla has a good niche that they have carved out for themselves. And we just don't see, like you said, 6 to 7 years probably is about right before we see anyone who's able to produce batteries that are of the energy density and reliability and performance characteristics.
Nice. Okay. And on the list here, the last one is FSD chip, full self-driving chip. He's 10 years ahead. That's crazy how far ahead they are there. We know that Tesla is one of the, an AI company, a software company. Even they make their own chips. They've created their own supercomputer with Dojo. But 10 years. Now, this is not just full self-driving, right? This is also software, which it doesn't mention here, which we know that the other legacies, they don't have software capabilities.
Yeah, and this is an area where I would probably disagree. And, I'm not sure. I know that they do a lot of work with defense, a lot of work with software. They know chips and they know software as well. But the advances that we're seeing in machine learning and artificial intelligence are just continuing to evolve so rapidly that I would be pretty surprised if actually pretty entry-level Snapdragon Qualcomm chips are not able to do a lot of what an FSD computer can do within 2 years. We'll see on that. But they do, they've had this now. If you go back to Hardware 3, they've had this since 2018. And so, yeah, we're probably just now about getting to the point where you could do with a Snapdragon processor what you could do with the FSD chip back in 2018. So, that is quite a few years, maybe not 10 years, but like 6.
Yeah.
So,
yeah. Okay. And it's the software that matters more than integration. So let's just quickly review this tweet here. This is the accountant, and he just replied to that tweet saying, with the great OEM EV pause, couple that with Tesla's announcement of their next gen car and the new unboxed model. This is the new list that's added, because remember, Munro's list was created in 2021. Tesla's now announced an unbox process, a single unit casting. Well, actually, I don't know if they ever announced that. 48 volt architecture and a structural battery pack. What's your comments on this list?
Yeah, I mean, the unbox process is huge. That's going to be a major move forward in Tesla's ability to reduce overall manufacturing cost. The single unit casting, I know that a lot of people have expected that, and they don't really understand that you can't do the single unit casting and the unbox process at the same time. When Tesla announced the unbox process earlier this year, that was basically saying we're never going to have a single unit casting for the vehicle, because we want to keep the front separate from the rear. We want to keep the sides separate from the front and the back as they progress through the manufacturing line, so that we can have more people working on that sub-assembly, and then we'll bring all those 4 sub-assemblies together at the end and then put them together. And so they don't want one giant car moving down the assembly line. They want to have multiple pieces of the car moving in parallel and then being integrated together at the end. The 48 volt architecture is also a big deal. Just like we talked about earlier, they're reducing the overall length of the wiring harness. By increasing the voltage, you can actually get the same power transmitted throughout the vehicle with 4 times less wire as far as weight is concerned. And so that's huge by going from 12 to 48 volts. And then on the structural battery pack, that's another thing that, we haven't seen those 4680. That's going to be really fun with the Cybertruck teardown, is to see what the 4680 structural pack in the truck looks like. We've seen it on a few Model Ys. It is very cool, and it does, reduces the weight significantly versus having to have a case for the battery that is structural, that is then filling that case with dead weight in batteries. If you're actually using them as a structural component, that's a significant step forward. The LFP packs coming out of China, a lot of times they're able to do very structural packs there. A little bit different when you have non-cylindrical cells, and they use the prismatic cells there. But those packs are also pretty good.
Thank you, Hans. Okay. So by the way, I just want to remind folks that if you want to go to my website, herbertong.com, you're going to be able to find the list of milestones of all the things that Tesla has done when they did it, all the way from 2003 up to now. So it's a complete list of milestones. And the final kind of thing I want to show folks here is this beautiful meme that I found, that it showed this is what the OEM manufacturers are on the left here, and they're pointing at a Tesla car. And if when Tesla is able to do this, they're just going to be saying, the German language at the bottom is, yeah, but their panel gaps are not as good as ours. So that'll be fun. We'll see, if they're able to catch up. But that's a great summary of all the things that's happened. Thank you, Hans. Follow Hans on his YouTube channel, Hans C. Nelson. He does a lot of good interviews, and he also does these deep dives as well. You're full of knowledge. Thank you, Hans. Talk to you later.